First of all, I want to welcome you all to my YouTube channel Cocktail Tube. Today, I'm going to show how to do FEA simulation using Solidworks software. Today's session comprises of two different analysis. One is static analysis and the another one is buckling analysis. Let's go for our section. See, this is the small overview of our simulation. This is our CAD model. This is the cross-section view of our CAD model, and in our simulation we are going to use LDPE material, which is low density polyethylene, and the load cases were taken in two different analysis. Was static analysis, which is the model distance to top loading, and the another one is buckling analysis. In buckling analysis, the load is act as an hydrostatic load, and the software we are going to use is Solidworks 2017, and the input model is underground tank. This is the input model. See, this is the material property of our simulation. These are the things we are going to consider at elevated temperature of 23 degrees centigrade. See, this is the material property of our LDPE, like elastic model, Poisson ratio, mass density, yield strength, thermal conductivity, and even specific heats. All the data are taken from the appropriate standard. Let's go for our section. See, this is our CAD model of our underground tank. This is a simple model. See, there is nothing in the inside the tank. I will show you the cross-section view. Yeah, it's a very simple model. So you don't want to worry about this model because it's a very simple model. Now I'm going to show how to do static analysis in this model. See, this is our load cases for our static analysis. The bottom section of our model are fixed at three different directions X, Y, Z, and the load was given under the top flanges of the CAD model. The load was given as around 5000 Newton. Let's go for our simulation. Just click the SolidWorks add-ins and click SolidWorks simulation. It will open. It will open simulation sector. See, from this simulation, go for a new study. And first we are going to do a static analysis. So I'm selected static analysis and named as resistance to top loading for our reference. Yeah, see here the tab was opened. Now I'm going to choose the material for our model. It will opening. Just decompress that one and go for custom material. I already saved the material properties in my custom material, so it will look like tank 1 pump purifier model. See, this is our LDPE, low density polyethylene. Just double click it. See, I already put each and every data for our LDPE material, so it's not a problem here. I'm just going to apply this and close it. See here, we'll check the material property was given. It's a single part model, so we don't need any connection for that, so we don't want that. And go for the fixture and right click it. I'm going to choose the fixed geometry because we are not going to do any roller or any fixed hinge fixtures. So I'm going to choose the fixed geometry X as my fixtures. Just turn around. See, I already picked the fixture as fixed geometry and select the bottom of the tank. Yeah, this face. Just click it and click OK. Yeah, you may see now the fixture was given appropriately, so no problem in that. Now I'm going to apply our external load. As I already said earlier, see the top of the flange I'm going to give as a 500 Newton. So right click it and give the load as force and select the surface of top flanges and give the load as 500 Newton. Yeah, all the load standard was SI unit. Just click OK. Now we have selected the load as well as the fixture condition, so we are almost done. Now I am going to move for our mesh generation process. Just click the mesh and right click it, create mesh. See the variation between coarse and fine. I am going to choose a fine mesh because it's a very simple model, so don't need to go for a coarse mesh. So I'm going to choose a fine mesh and get the most appropriate result for our model. Just move the cursor into fine and click OK. See the mesh generation process are now processing. It will quickly mesh. Yeah, see our meshing process was done appropriately. It's inside a tank. This mesh is almost fine. If you want to see the cross section view, yeah, I'm taking the default mesh settings. It's a tetrahedral. So meshing process are done. We have finished the meshing process, so we don't worry about anything in that. And just go for the solver. In solver, it's very easy here in Solidworks. Just I click the whole process and just run. And gonna start. Yeah, the solving process started. I hope it will solve immediately. Maybe take 1 to 2 minutes around time, because we are given a fine mesh, so it's take little bit time, not more than. I hope yeah, the result was established successfully. See, this is the stress, one measure stress of the result what we have got from our simulation. This is the displacement. See the model, the deformation are implemented due to our appropriate load condition. The strain, yeah. If you want to see the stress in animated image, just right click it the result and go for animation. It's gonna start. Yeah, just increase the, just decrease the speed, it will show you nicely here. The maximum is 2.3 in 10 power 5. I think the maximum stress acted in the bottom. Yeah, see, due to the load condition, the maximum stress are acted in the bottom surface of the tank. Just if you want to save this animation view, it's not a problem. Just click the save the file and view the media player and click it OK. If you do that, means the file will automatically save. Now I don't want to save my file, so I just want to stop this animation. Similarly, if you want to see the displacement, same process. For proper view, I'm going to choose isometric view and right click the displacement and go for animation. Yeah, it will start. See, if you want to see in more appropriate way, see it will find. See the displacement. So the static analysis was performed successfully. There's no problem in that. Yeah, the first load condition was perfectly done. As I told you already, the first load condition, the analysis was performed based on our input requirement like 5,000 Newton on the top flanges, and the bottom surface are arrested in 3 different directions. So the first load condition was successfully finished. Now we are going to do the second load condition, that is the buckling analysis using hydrostatic load condition. In this case, we are going to fix two different faces over the model. The first fixture was considered as the bottom of the surface, as we have done earlier in the static analysis, and the second fixture was considered in the central flange, that means the first flange of the CAD model here. And the hydrostatic load was given as a given at specific gravity level 1.0, that is 9087 Newton per meter square. The tank is fixed at the bottom, as I said already, clearly XYZ. The central flange is fixed at the first flange. Yeah, we are going to choose the local coordinates system because the load was maximum at the top, and while going for the top of the tank it will minimum with a uniform distributed load. Based on the hydrostatic load, the load was maximum at the bottom level. So I'm going to do the simulation in or the model in buckling analysis. Just click the new study and go for the new study. Yeah, in that, instead of starting we have to select buckling. I'm going to change the name as hydrostatic load condition, or hydrostatic load is enough. Just click OK. Yeah, it will open the new tab here, hydrostatic load. We have already done the return to top loading in like static analysis. Same process, just select the material, go for the custom materials and pick the low density polyethylene, apply it and close. Yeah, we have successfully applied the LDP material. Now we are going to fixture, as we said already, we are going to fix the two different position. Another one is the bottom position, and another one is the first flange. So just right click the fixture and Fixity Geometry and choose the bottom surface of the model. Just fix it and click OK. Similarly, I'm going to fix another one, that is top flange. Pick that and select the face of the first flange. Select it. The model was arrested in 3 different directions, XYZ. Just click OK. Yeah, so we have successfully selected the fixtures for our appropriate simulation. Now we are going to do external loads. As we told already, we are going to test the load condition at SG level 1 with the respective coordinate system. We are not here selected the coordinating system, so I'm going to select the coordinate. See, I already created that one. I will show you how to select the coordinate system. Just delete that one. First I'm going to select the point to create coordinate system. Just click the reference plane and go to the point and click the top surface. See, the center of the faces was selected as the point. Just click OK. So we have successfully created a point. Similarly, we are going to do the coordinate system. In the coordinate system, we are going to choose the reference as the point, and we are going to do the load condition in hydrostatic in downward force. So we have to choose the y direction is downwards. So just right click that one, click the point. Yeah, we got the y direction is downwards, so it's highly sufficient. Just click OK. Now we have selected the coordinate system. Now go for the hydrostatic load condition. Yeah, we have successfully generated the coordinate system. Now I'm going to give the load. Just right click it and give the pressure load, that means uniform distributed load. So we have to select each and every faces of the tank in order to enumerate the simulation successfully. I'm selecting all over the model. Yeah, the bottom surfaces also we need to select. There's a lots of fillet area is there, that's why it's take a little bit time. We need to select all the necessary surface in order to enumerate the simulation. I am selecting all the necessary surfaces. I hope I have selected every surfaces. Yeah, we don't need to give the load condition here because the top surface. I hope I have selected each and every surfaces for our simulation. In that I am going to do the non-distribution. I already selected the coordinate system. I just clear the section and choose the scale as meter and select the coordinate system as this, and need to change the equation as y because the load was given as a downwards, so I'm going to choose the equation as in y direction for our respective coordinate system. Just click OK, and the load was 9807 Newton per meter square. Just click OK. See, we have successfully given the load on our requirement. See, the red arrow shows the maximum was in the bottom position, and it will further decrease while going to the upper surfaces. So load fixture and the load condition was appropriately given, so the boundary condition was given well. Now I'm going to for mesh generation process. As we said already, go for a fine mesh and click OK. Yeah, the meshing process gonna finish now. Yeah, it will finished. It will fine now. Similarly, just we have done already earlier in static analysis. Just go right click the whole model and go for the run. It will solve the whole model. In buckling analysis, the amplitude was gonna show how the buckling was happen while given the hydrostatic load to enter model of the tank. The maximum load acting at the bottom of the surface, and it will further decrease when while going to the top surfaces over the tank. I think it will take a little bit time. I hope it will gonna finish solving in couple of minutes. You can wait here. It will take maximum 1 to 2 minutes, I hope. We may try in different model like medium density, polyethylene, and different further material for our based on our requirement. For in our cases, I simply choose the LDPE material because the most tankers was available in polyethylene. The underground storage and wastewater management tanks were made in LDPE and as well as MDPE as well as HDPE, like polyethylene tanks material. it will still running. I hope it will take more time or not. Let we wait for a couple of minutes. Yeah, it's finished now. uh, Now you have seen the respective buckling happened over the CAD model. Just hide the loads as well as the fixture to enumerate the appropriate view. And I want to hide the coordinate system. Yeah, see, the model was buckled here. Just want to hide the deformed result means it will show the respective manner the amplitude was. See, you may see the deformation level is very low in the bottom of the tank because we already fixed here on the bottom surface as well as this flange on the first two flanges. So the deformation level is minimum here. The deformation is maximum at the center of the tank in all of the four different directions. If you want to see the animated view, just click the deformed result, and as a result just to go for the right click the result and go for animation. It will gonna start zoom. Yeah, see, you may see the perfect deformation result for our buckling analysis over the tank. So this is a simple simulation in Solidworks using the simple CAD model of underground tank. So we have done the both the static analysis as well as the buckling analysis using static load, hydrostatic load. So these are the things we have learned from today's session. I hope it will help you out in SolidWorks softwares, especially in FEA. So guys, I need your support. Based on your response, I'm going to upload more number of video in both the sector of CFD as well as FEA. And if you like this video, just share with your friend circle, and don't forget to subscribe my channel because it will boost me up. And English is not my bilingual language, so please take my apology for any mistake I have made in this video. Thank you so much for watching this video. I am going to sign off now. Thank you so much. I need your support, so please subscribe the channel. And once again, thank you so much.